Hello, everyone. Welcome to Grade 10 Physical Science revision for Term 3. I hope you are doing well wheresoever you are. Today, I want us to do a question paper from KwaZulu-Natal Province, which is a paper from the Department of Education. This paper was a common test which was written in September 2023, and it was for 2 hours with 100 marks. And you can see that there were some instructions that were given to learners. These instructions, let's actually learn to follow them. They would help us to make our work easier in terms of being neat, as well as for the one who would be marking your paper to actually get to follow easily through your answers. Like, for example, here they said start each question on a new page, and then they later said leave one line between two subsections, for example, between question 2.1 and question 2.2. So this is a format that they want you to actually get to follow, so that it's easier for those who will be marking to actually get to follow through your answers. And also they said round off your final numerical answers to a minimum of 2 decimal places. So before you start answering your question paper, please read through instructions that are given on that question paper. It helps you as well as the examiner. So let's get started. The question paper is divided into 3 sections. We have got a multiple choice section, which is question number 1.1 up to question number 1.10. And then we have got section A for physics, section B for chemistry. So for multiple choice, you are just supposed to choose either A, B, C, or D. Let's hear what question number 1.1 is saying. Two forces act simultaneously on a box so that the resultant force is 120 newtons east. One of the forces is 70 newtons west. What will be the other force? That's the question. What will be the other force? So we can see that we have got two forces that are acting on a box, and then there is a resultant force that is 120 newtons. So the first thing that we need to do is to define what a resultant force is. So you will see that a resultant force is the sum of the two forces that are acting on that box. So here we can actually get to define our direction. So we will choose east as positive. So our east direction is positive. So this 120 would be a positive. And then we are given the 70 newtons, which is going west. That would be a negative. So that would be negative 70. And then we are looking for the other force. So all we needed to do was to transpose this, and then it was going to give us 120 plus 70. So our F2 was going to be 190 newtons. So you can see that this is a positive, and we chose east to be a positive. So our answer was going to be B, 190 newtons east. Let's go to question 1.2. So question number 1.2, you were given a position time graph, and then now they are saying that the position time graph of an object is shown below, and then which one of the following velocity time graphs is correct for the motion of the object? So they are saying that from this position time graph, interpret it so that you can be able to draw, from this position time graph, you are able to draw a velocity time graph. So what is it that we know from a position time graph about velocity? We know that our gradient from this position time graph gives us the velocity. So if I can follow through this graph, you can see that it's a smooth, uniform curve. So at some point in time, the gradient, you can see that the gradient is changing uniformly. And then the other thing is you can see that the gradient is starting at a higher positive and then going decreasing as you go up until where it's 0 here, and then it starts decreasing from a lesser negative to a higher negative. So we are just simply looking for something that starts at a higher positive from our velocity time graph, goes to 0, and then passes through uniformly. So our graph that we were looking for was A. Now let's go to the next question. You'd say that here they're saying that the instantaneous velocity of a car can be defined as. So for 1.3, you were supposed to choose an option that defines instantaneous velocity. So what is instantaneous velocity? Instantaneous velocity, this is velocity at a particular time. So let's look for an answer that actually defines velocity at a particular time. So you see that on option A, it was saying the total distance covered by the car divided by the total time. This is average speed. And then the second option was saying the total distance, the total displacement of the car divided by the total time. This is average velocity. But till now we are looking for velocity at a particular time. So these two already, they are out. And then C was saying the rate of change of displacement of the car at a particular time. So rate of change of displacement is velocity, and then they are saying at a particular time. So this is the velocity at a particular time. So this is our answer. So option C was going to be our answer for question number 1.3. Instantaneous velocity is velocity at a particular time. Now let's go to question number 1.4. Which one of the following combinations consists of two vector quantities and one scalar quantity? So we need to define what a vector quantity is and what a scalar quantity is so that we can be able to choose from the options that are given two vectors and one scale. So we know that a vector quantity is a quantity that can be defined by both its magnitude and direction. Whilst a scalar quantity, it's a quantity that can only be defined by its magnitude only. So let's look at our options that are given here. Option A, we have got speed, distance, and mass. So we know that speed, it's a scalar. It can only be defined by its magnitude. Distance is also a scalar. Mass is also a scalar. You cannot say 10 kgs to the west. You can only mention 10 kgs. As well as also we have got time. Those are scalar quantities. So A is already out because we've got three scalar quantities. And then let's go to force. Force is a vector. You can define both its magnitude and direction. Acceleration is also a vector. And then distance is a scale. So we are looking for two vectors and one scalar quantity. So our answer here was going to be a B. Even if we went to C, you would see that this one is a scalar. Acceleration is a vector. This one is a scalar, so it's also out. This one is a vector. This one is a vector. This one is a vector as well. So you would see that here we've got three combinations of vectors. So our answer was going to be B, where we have got force, acceleration being vectors, and then distance being a scalar quantity. Let's go to question number 1.5. Which one of the following statements is true? An object experiences positive acceleration when it is moving in the, so we need to choose an option that defines positive acceleration. So what is it that we know about positive acceleration? In terms of, I say there is direction and then as speed. So for us to get what we refer to as positive acceleration, it's either we have got positive direction and then there is also a constant there is also a constant increase in the what, in the speed. So if you have positive direction and a constant increase in the speed, increase of speed, you would have what, positive acceleration. And also when you have a negative direction and then a constant decrease, so it's either you are having a negative direction and a constant decrease, or else you are having a positive direction and a constant increase in speed. That's when you have positive acceleration. So let's look at our options given there. Option A is saying positive direction at a constant speed. Once you have got constant speed, when there is no changing speed, your acceleration is equal to 0. So this one is out. And then you have got negative direction experiencing a constant decrease in speed. Yes, we need negative direction and a constant decrease. So this would actually be our answer. So let's look at option C. Positive direction, experiencing a constant decrease. These ones, they are opposite, so it's out. And then you have got negative direction, experiencing a constant decrease, opposite again, so they are out. So it's either you have got a positive direction and a constant increase, or a negative direction and a constant decrease. So our answer was going to be B, negative direction, experiencing a constant decrease in speed. So for you to have acceleration, you need your speed to be changing. So answer for 1.5 was going to be B. Now let's go to question number 1.6 and question number 1.7. So now you see that on question number 1.6, we are now starting on chemistry. We have been doing physics for multiple choice. So let's see what question number 1.6 is saying. For which one of the following quantities of substances will the total number of atoms be equal to the Avogadro's constant? So here we are looking for the total number of atoms, which will be equal to our Avogadro's constant. So now, what is our Avogadro's constant? We know that our Avogadro's constant is given by 6.022 times 10 to the power 23. So we need the total number of atoms within each of these substances that will give us a total of that. So let's look at option number 1. You'd see that for option number 1, I have got 1 mole of carbon dioxide. So what we need to look for here is how many atoms are in each option here. And out of those atoms, are they equivalent to that number in terms of the number of entities that they will have? So here we can see that we have got 1 atom for carbon, and then we have got 2 atoms for what? For oxygen. So these ones will be equal to 3 atoms. So now you will see that these 3 atoms are in 1 mole of this substance. So it will be 3 atoms times 1 mole, of which we know that 1 mole is equivalent to this number. So this one will be 3 times 6.022 times 10 to the power 23. So this one is out because we are only looking for something that is equivalent to exactly 6.022 times 10 to the power 23 entities. So this will be entities or else particles. Now, 1 mole of nitrogen, you can see that we have got 2 atoms of nitrogen there. So we have got 2 atoms, and then we have got what? 1 mole. So this will also be equal to 2 times 6.022 times 10 to the power 23. So this is also out. And then here we have got 2 moles and then 2 atoms of nitrogen. So it will be 2 atoms times 2 moles. So you can see that this becomes 4 times 6.022 times 10 to the power 23. So that one is out as well. And then we have got 0.5 mole of hydrogen molecule, which is just 2 atoms of hydrogen. And then we have got what? 0.5. So this one would actually be equal to what? To 1 times 6.022 times 10 to the power 23. So this is the option that has got the total number of atoms equivalent to the Avogadro's constant. So our answer there was going to be for 1.6 was going to be D. And then now let's look for 1.7. Which one of the following is correct for the number of oxygen atoms in 3 moles of carbon dioxide? So we have been given 3 moles of what? Of carbon dioxide. 3 moles of carbon dioxide. And they want the number of oxygen atoms. So you can actually get to see that here for carbon dioxide, I have got 2, what? I've got 2 atoms of oxygen. So here I've got what? 2 atoms of oxygen. And then from my answers, it is given in terms of entities. So we need to find entities that are equivalent to what? That are equivalent to 2 atoms of oxygen times 3 moles. And we know that in a mole, there are 6.022 times 10 to the power 23. So the number of the correct answer there was going to be 6 times 6.022 times 10 to the power 23. That was going to give you the number of oxygen atoms in 3 moles of what? Of carbon dioxide. So the answer there was supposed to be what? Was supposed to be D as well. So now let's go to our next question. Now 1.8 is saying which one of the following expressions gives the percentage of nitrogen in calcium nitrate. So we need the percentage of nitrogen in this compound. So for us to know the percentage of nitrogen in this compound, we need to find its composition in terms of what? Of, let's get to say, its mole composition. So we would assume that everything would be per unit mass. So we'll get to say, let's calculate its molar mass. So let's calculate the molar mass of that compound. When we calculate the molar mass, we are also going to actually get to see that in terms of its composition, how much of the nitrogen makes the total molar mass. So you can see that the total molar mass would be given by one atom of what? Of calcium, and then it will be given by 2 times of nitrogen. So you'll be having 2 atoms of nitrogen, and then you'll be given 2 times 3. It will be 2 times 3 atoms of what? Of oxygen. So one atom of calcium has got a relative atomic mass of what? That is what we need to look for. What is the relative atomic mass for what? So let me actually get to look for our uh, periodic table so that we can actually get to check it together. What is the relative atomic mass for calcium? This is calcium. And on our calcium, what we need to know is on a periodic table, when you're looking on a periodic table, these Roman numerals, which is 1, 2, 3, 4, 5, 6, 7, 8, they give you the group in which your element is in. And then these ones, they give you the period. And then when you locate your element, you would know that it will look like this. This was an example that was given. And then this number would give you the atomic number, which is relatively the number of electrons of each element. So this determines the outer shell of our what? Of our element, to say how many valence electrons will we be having, so that it determines how each element would be bonding. Like for example, group 8 elements, they have got what we call stable elements, or else let's get to say stable shells, the stable outer shells. So they are non-reactive because their outer shells are already filled, so they are stable, so they are non-reactive. But if you look at maybe, for example, fluorine, chlorine, bromine, and iodine, they have a deficiency of 1 electrons on their outer shells. We take it from this to say that if I want to fill the outer shells of each element here, I will look at the number that I'm given on top here, which is atomic number. So this determines our outer electrons, or else the number of protons, because we know that the number of protons in an atom are equivalent to the number of electrons. So this gives us the number of electrons and how that element would be bonding. And then we come to this number. This determines the relative atomic mass. This is the one that will give us the molar mass of each element. And then this number that is here, this gives you the electronegativity of each element, which determines the amount of how hungry for electrons each element would be, the electron affinity. So this determines if our element would be donating or else would be receiving how ready is it for the element to actually get to receive electrons or else to donate electrons. So now let's look at our calcium. We have got an atomic mass of 40. And then let's go to what? To nitrogen. Our nitrogen, we've got an atomic mass of 14. And then let's go for oxygen. We've got an atomic mass of 16. So these are the numbers that we will be using to actually get to determine the molar mass of our compound that we are given there. So let me just go back to our question and let's get to see what they wanted us to do there. So here they wanted us to find the molar mass of calcium nitrate, where we have got calcium, nitrogen, and oxygen. So we found out that the atomic mass of calcium was 40, the atomic mass of nitrogen was 14, the atomic mass for oxygen was 16. So you would see that when you're now calculating the total molar mass, you would come and say 1 times 40, which is equals to 40, plus 2 times 14, because there are 2 atoms of nitrogen in this compound, that will be equal to 28. And then you would say 6 times 16. So it will be going to be 6 times 16 for our what? For our oxygen. If you say 6 times 16, you are going to get 96. After getting 96, we need to find the total molar mass of everything. So we will add everything there. So by adding everything, we're supposed to get 164. So the molar mass is 164 grams per mole. So for each mole of this compound, we've got 164 grams. Now we are saying, what is the molar composition of nitrogen within this compound? You would see that it is 28 grams per mole out of a total of 164. So the percent composition of nitrogen would come to be, let's get to say the percent composition of nitrogen in this compound would be 28 divided by 164 times 100%, because we are looking for the percent composition. So our answer was supposed to be equal to B. Now let's go to the following question, which is saying that consider the balanced chemical equation below. Nitrogen gas plus hydrogen, they react to form ammonia. So we are saying that 1 mole of nitrogen is reacting with 3 moles of hydrogen to form 2 moles of ammonia. And then they are saying what volume of ammonia gas will be produced when 2 decimeter cubed of nitrogen reacts completely with excess hydrogen. So what we need to do here is to find the molar ratio of nitrogen being used as well as that of ammonia being produced, because we are given the volume for nitrogen. So you can see that 1 mole of nitrogen is actually producing 2 moles of ammonia. And then by doing that, you can actually come and calculate your number of moles of nitrogen, so that you'll be able to relate with the number of moles of ammonia being produced, so that you can be able to calculate the volume of ammonia. So we know that 1 mole of gas is equal to 22.4 decimeter cubed of volume. So we get to say 1 mole of gas occupies 22.4 decimeter cubed in volume. So if we know that the volume of nitrogen is 2 decimeter cubed, how many moles is it equivalent to? So we get to say that the number of moles for nitrogen, let's get to say the number of moles for nitrogen is going to be equal to 2 divided by 22.4. So that was going to give you, if you say 2 divided by 22.4, that was going to give you 0.089. Now we now know the number of moles of nitrogen. Let's now look at the number of moles for what? For ammonia. Because we know the mole ratio in between nitrogen and what? And ammonia. They are in relation to as 1 mole of nitrogen has 2 moles of ammonia. So for us to find the number of moles of ammonia, we need to multiply the number of moles of what? Of nitrogen. So that would be 2 times 0.089. And then this was going to give you 0.1785, and then we get to round off to 2 decimal places. That was just going to give you 0.18. After doing that, now we get to say that we have got 0.18 moles of ammonia. So this mole of ammonia, how much volume is it going to occupy? That's when we get to say that we now get to multiply by a factor of 22.4 decimeter cubed, because we know that 1 mole occupies 22.4 decimeter cubed. So this one was going to give you 4 decimeter cubed. So we now need to look for an answer which says 4 decimeter cubed. So our answer was going to be B. Now let's go to question number 1.10, which is question number 1.10, which is our final question when it comes to multiple choice questions. So the question was saying, which one of the sample of gases below will have the largest number of molecules if the mass of each of the samples is the same? So we are told that the mass of these samples here is the same. So they want us to find the one with the largest number of what? Of molecules. So you would see that since the mass is the same, we are saying that we have got the same mass. How do we find the number of what? Of molecules. We need to find the number of moles of each sample of gas. So how do we find that? We know that the number of moles is given by mass divided by its molar mass, because we are given these in terms of their mass, and they say that the mass is the same. So we would use the symbol of small m to represent mass. So we need to calculate the number of moles for water, and then get to calculate the number of moles for what? For nitrogen, and then get to calculate the number of moles for carbon dioxide, and then get to calculate the number of moles for chlorine, so that we can be able to actually get to compare these. So for us to do that, we need the molar mass for water, molar mass for nitrogen, molar mass for carbon dioxide, and then for chlorine. Now, for water, we know that if we look on our periodic table, the atomic mass for hydrogen becomes 1, and then you multiply by 2 atoms, plus for oxygen, it becomes 16. So this was going to be 2 plus 16, which is equal to 18. That is the molar mass for what? For water. So if I now want to represent this as in terms of the number of moles, I would have just came and said mass that I'm given, which is m, divided by 18. And then I would come for nitrogen. I know that each atom of nitrogen has got an atomic mass of 14, multiplied by 2 to be 28. So the number of moles will be m over 28. And then I come for carbon dioxide. One atom for carbon dioxide has got an atomic mass of 12, and then oxygen 16. If I multiply by 2, that would be 32. So if I say 12 plus 2 times 16, this should give me what? 44, because this one will be 32 plus 12, it will be 44. So my number of moles would be m divided by 44 for carbon dioxide. And then for chlorine, I know that chlorine on my periodic table, each is having an approximately atomic mass of 35. So if I say 35 by 2, that would give me what? 70. So I would actually have m over 70. Now I need to actually get to compare these four. So you would see that at the end of the day, when you're now comparing this number of moles, you would need to find the largest and the smallest. So I would have to actually get to group them from their what? From their largest. So I would get to say m over 18 is greater than what? M over 28. Why am I saying so? If you divide by a smaller number, the number that you're going to get will be greater than when you divide by a larger number. So this would also be greater than M divided by 44, which will be also greater than M divided by 70. So you would see that water is having the largest number of molecules. So our answer there was supposed to be equal to A. Now let's go to our next section. So our next section is section A, that is to do with physics. And then we have got question number 2. And then they are saying start on a new page. Now let's hear what they are saying. They are saying that two friends, Tom and James, are training on an athletics meeting on a sports field. They're training for an athletics meeting on a sports field of length 200 meters. Both friends, they start from the middle of the field at point A. So we are told that point A is the middle of our field. And then the total length of this field is 200 meters. Now they are saying Tom runs using cones. The first cone is placed 50 meters east of the starting point, and then while the second cone is placed 40 meters east of the second coin. So we can see that all this information is represented here. And then now they are telling us that Tom runs along the following route. Let's get to see what follows. So they are telling us that Tom runs along from the starting point, which is A, to cone 1, and then he turns around to the starting point, and then he runs again to cone 2, and then he turns around to what? To cone 1. So now they're saying define the term displacement. So you would see that displacement is simply the change in position. So you would come and say displacement. Let me just bring it up a bit. I want to create space so that we can be able to answer these questions. And then we can see the question as well. So we are given our compass there to define our directions as well as everything on this. So we say that displacement is the change in position. So your displacement is simply the change in position. Now they're saying that write down the final position of Tom relative to the starting point. So Tom started at point A, and then he went to cone 1, he came back. He went to cone 2, he came back to cone 1. So his final position is on cone 1, which is 50 meters towards the east of point A. So here you would have said 50 meters east. So this is 50 meters east relative to the starting point. Now let's hear the second question, the third question. 2.3 is saying the complete route described above took Tom 30 seconds to complete. Determine his average speed. So we know that when we are looking at speed, let me just bring this to this side. When we are looking on speed, let me answer question number 2.3 here. So I would actually get to say 2.3. We know that speed is equal to the total distance moved divided by the time taken. So now, what is the distance that Tom moved? It is 50 meters going 50 meters back, that is 100 meters. So you would have your distance being 50 plus 50 plus he also moved 90 meters, that is 90 plus, and then he came back to 40, that will be 40 meters. And then they're saying this total distance was covered in 30 seconds. So the total distance covered there would be 100 plus 90, which is 190 plus 40, 230. That is 230 meters divided by 30 seconds. So your total speed there was just supposed to be 230 divided by 30 seconds. If you punch in your calculators, you would get 7.66666 but we round off to 2 decimal places, and then it will be 7.67 meters per second. Some they are used to this notation when you are representing your speed, which is just meters per second. It's just the same thing. It's just the same thing. So that was your speed there. Now let's look at 2.4. Let's look at 2.4. Now 2.4 is now saying that James runs from the starting point A. Let me just bring it up so that we get to see the whole question. James now runs from the starting point A due east to cone 2, and then he immediately turns around and runs in a westerly direction until he reaches point B, and point B lies on the boundary of the field due west of the starting point. 2.41 is saying determine the total time taken by James if his average speed is 1 meters per second slower than of Thomas. So we know that the average speed of James, so the speed of James there, you would see that James' speed is actually equal to 7.67 minus 1 meters per second. That will give you 6.67 meters per second. And they are now telling us that James moved to cone 2, and then he later went back to cone, he moved from A to cone 2, and then he ran to point B, and they're saying point B is at the end, and you can see that this is the center of the field. So I assume that the distance from here to there is 100 meters. So you would see that the distance here is just 100 meters. So now they're now saying that calculate the time it took to actually get to run that whole journey from here to cone 2 and back to point B, given that the speed is 6.67 meters per second. So now let's calculate the time taken for James. So what we are going to do is I'm going to create some space there. So the time taken for James would be given by to say that the speed of James being equal to the distance divided by the time taken. So the total distance was to say he ran 90 meters going this side. So it would be 90 plus another 90 plus from point A to point B is 100 meters. It will be 100 meters, all divided by the total time that we are looking for. And then we have got the speed, which is 6.67. So for us to find the time now, we will interchange these ones, so that your time taken will simply be equal to this total, which is 90 plus 90 plus 100. That will give you what? 280. And then you all divide it by what? 6.67. So now let's punch in our calculators and let's see what will be that answer if we get to say 280 divided by 280 divided by 6.7. That was going to give you a total time of what? If I say 280 divided by 6.67, that was going to give you a total time of 41.98 seconds. 41.98 seconds. So that was the total time that James actually took to run that distance. So we are saying that our total time taken was 41.98 seconds. So now they are saying calculate the average velocity of James for the entire motion. Now you now have the time taken by James, and the time taken by James is 41.98 seconds. Now they're saying calculate the average velocity. So now for the average velocity, you need to consider the change in position. His final position is B and he was at A. So the displacement that was moved, it's only 100 meters. And along that change in position, we took 41.9 8 seconds to change that position. So our average velocity will simply be equal to the change in displacement divided by the time taken to change that displacement. So our average velocity, let's get to say that average velocity will be equal to change in displacement, which is change in position, divided by the total time it took that change in displacement. So the change in displacement is 100 meters divided by the time it took to change that displacement, which is 41.98 seconds. So if you are to divide 100 meters divided by 41.98, that will give you 2.38 meters per second. So that was the answer for 2.42. So let's go to the next question. Our next question is now question number 3, and it is saying the velocity time graph below represents the motion of a car over a period of 22 seconds. The car initially moves north. So they have told us that the car initially moves north. So positive direction is in the north. So now they are saying describe how the velocity of the car changes in the time interval from 0 seconds to 4 seconds. How did our velocity change from 0 to 4 seconds? You can see that the velocity increased uniformly from rest, which is 0, to 20 meters per second. So you would come here and you say the velocity increased uniformly. That will be from, let me just get to create space. It increased uniformly. That will be from 0 to 20 meters per second. So it increased uniformly from 0 to 20 meters per second. That was from 0 to 4 seconds. And then what about from 19 to 22 seconds? You can see that 19 is here, which is a negative, and then it actually decreased to 0 because it came from a negative. So a negative, it means that it was moving in the southerly direction. Now it came to 0, which is at rest. So here it was at rest. So the velocity also decreased uniformly, but now it is coming from a negative velocity of 12 meters per second, which is 12 meters per second south to rest. So here you would have said that the velocity decreased. So the velocity decreased uniformly from 12 meters per second south to rest, which is just 0 meters per second. So now let's look at our following question. Now they are saying, determine the displacement of the car during the first 10 seconds of its motion. So the first 10 seconds is this. And then they are saying, determine displacement. We need to understand or else to know what does the velocity time graph tells us about displacement. So we know that the area under a velocity versus time graph is equal to what? To displacement. So the area under the what? The velocity time graph will give us the what? The displacement. So we have been given the time up until to what? To 10 seconds. So we need to find the area under the graph up until here. So it's from this, the total area here. So you can see that this shape is actually a trapezium. So you can calculate the area of a trapezium. So option A was actually to get to calculate the total area of a trapezium. Let me actually get to use this side. You would actually get to say that 3.2 would be to say that your displacement would be equal to area which would be equal to either base 1 plus base 2 all over 2 times the height, or else you would come and divide that shape into its two shapes that you have, that you know, which is going to be shape A and then shape B. So this was going to be shape A and this one is shape B. So shape A, it's a triangle. You can calculate the area of a triangle. Shape B, it's a rectangle, the area of a rectangle. So you would have just came and said that the area that we were going to use there was going to be, for the triangle, it was going to be half base times height. And then for the rectangle, it was going to be length times its breadth. So you would have chosen which one to use. So for me, I can either choose the above, which is base 1 plus base 2 times its height. I only need to determine base 1 would be this base, which is 0 to 10, and the base 2 would be from 4 to 10. So this one is 10, this one is 10 minus 4, that one is 6. So you would actually get to see that here I would be having 10, and then there I would be having 6, and then my height would be just 20. So here I would have just came and said 10 plus 6 all over 2 times my height, which is 20. So if I do that, I would actually get to find the area being equal to 160. So this one was going to be 160 meters. Or else I would have used to say half of this base, which is 4, that base is 4, times its height, which is 20, plus the length, which is actually what, 20, times 10 minus 4, which is 6. So the other option was to use the areas, the two areas which we're going to give you, to say that half of 4 times 20 plus 20 times the base, which is going to be 6. They were all going to give you the same answer, which is 120 meters. So you would actually get to know that the displacement under a velocity time graph is given by the area. Now let's see what they are saying here. They're now saying define acceleration. They are now saying define acceleration. What is acceleration in words? Acceleration is simply the rate of change of displacement. So you would have said that acceleration is the rate of change of velocity. Rate of change of velocity. I think I said displacement in the first place. Correct that. Acceleration is the rate of change of velocity. So that is acceleration in words. Now they are saying determine the value of x on the graph, given that they said the acceleration of the car from the 16th second to the 19th second is equal to the acceleration from the 10th second to x seconds. So we need to find the acceleration from here to here and compare it from the acceleration from here to there. So how do we get to do that? Let me just get to show you what they are looking for. They are looking for the acceleration which is here being equal to the acceleration that is there. How do we calculate that acceleration? We need to find the final velocity here and the initial velocity there and the time taken to change that velocity, the final velocity here and the initial velocity here, and the time taken to change that velocity. So we are actually going to, let's move this up so that we can be able to work from down there. That is where we have got enough space. So 3.32, we are going to have 3.32, saying that the acceleration, to say that the acceleration is given by v final minus v initial over the time taken. That is how you calculate your acceleration. Now they are saying that the final velocity at the 19th second was equal to what? You can see that at the 19th second, the velocity there was equal to negative 12. And then here it was 0. And then here the final velocity, it was 0. The initial velocity was 20. So those are the values that we are going to use. So given that information, we would actually have come and say that negative 12 minus 0 divided by 19 minus 16 should be equal to 0 minus 20 divided by, we actually get to say that x minus 10. So from our information, let's just go back and see if everything tallies. You can see that from our information, we are saying that this is the final velocity here, negative 12 and 0. And then here we have got 0. And then our velocity initial was 20. So we said negative 12 minus 0 divided by 19 minus 16. And then we have got 0 minus 20 divided by x minus 10. So that is how you would calculate your acceleration, because they told us that those two accelerations, they are the same. So now, given that, we now get to say that negative 12 on top divided by 3 should be equal to negative 20 divided by x minus 10. So maybe I should have just represented my x in this format so that I can actually get to say, how do I find this? I have to cross multiply by that x minus 10 so that these ones, they will cancel out this side, and then it will come this side, I multiply by x minus 10. So you would see that at the end of the day, I would be having something that looks like this. So if I say negative 12 divided by 3 to be negative 4, so I'll be having x minus 10 times a negative 4 being equal to a negative 20. So I can actually get to divide throughout by negative 4. I divide by negative 4, divide by negative 4. These ones, they cancel out. This side, I'm left with what? I'm left with 5. And then this side, I'm left with x minus 10. So my x would be equal to 10 plus 5. That is just 15. So this one would actually be equal to 15 seconds. So that was going to be the time for what? That was going to be the time that you're looking for. This is just 15 seconds. So that is the time that you're looking for. Now let's go to the next question. So you would see that our next question is question number 4. Our next question is question number 4, which is saying that in the diagram below, they're telling us that in the diagram below, a robot, which is a traffic light, and a signboard are 500 meters apart. This is the information that they represented here. And then they're telling us that these two cars, car A and car B, both they pass this traffic light, which is the robot, at the same time. And then car A takes off from rest and accelerates at 1.2 meters per square second, and car B travels at a constant velocity of 27.78 meters per second. Both velocities, both the vehicles are traveling in a easterly direction. So both of these cars, they are going this side. Now, what is it that they want from us? They are saying use suitable calculations to determine which vehicle, car A or car B, will reach the signboard first. Which one of these two cars is going to reach the signboard first? So how do we get to determine that? We need to list down the information that we are given for either car A and then for car B. Once we have got all the information, we would be able to calculate the time each took to reach the signboard, and then we get to compare those times. Then we would know which one actually reached first. So for car A, I have got my initial velocity being equal to 0, and then I've got an acceleration of 1.2 meters per square second, and then I have got the change of displacement being equal to 500 meters. That is the information that I'm given for car A. For car B, I only have got the uniform velocity, or else let me say the constant velocity, which is initial of car B being equal to final for car B, and they're telling me that it's 27.78 meters per second. This tells me that the acceleration here is 0. And then the change in displacement is the same. It's also 500 meters. Now let's use this information to actually get to calculate the time each took. So we are looking for the time each took. So here to be time for A and then time for B. That is what we are looking for. So let's create space so that we can be able to use that information to calculate the time for each. So how do we calculate the time for each? We can actually get to use the equations of motion. We can actually get to use the equations of motion. And the equations of motion, what do they say? We have got the one that says that V final is equal to V initial plus acceleration times time. And then V final squared is equal to V initial squared plus 2 times acceleration. And then we now have got what? Our change in Y. And then we then later come to say that we have got, sorry, here it will be change in X. This one would be change in X, not in change in Y, sorry there, because we are looking at motion in one dimension. And then this one will be change in X is equals to V initial times the time taken plus half AT squared. So we choose from these equations of motion to determine which one is going to actually get what? To get there first. So we want to determine time. So for us to determine time using those equations, we actually need to actually get to choose which equation is suitable for our scenario. So you can see that for car A, let's start for car A. For car A, we would see that we are given initial velocity, we are given the acceleration, and then we are looking for the time, but we are not given the final. So we cannot use this one. For car B, we are not also given the final velocity. Now, the equation that we can use is just for what? It's actually for delta x is equals to VI t, because we have initial velocity, we have acceleration, and we are looking for time. So I would come and say that my change in displacement is equals to initial velocity times time plus half of my acceleration times time squared. So here my initial velocity is 0, and I'm actually going to say that the acceleration is 1.2, that is the given, and then we are looking for our total time. And then the change in displacement is equal to 500. So we actually need to see or else determine this time. So we would multiply throughout by 2 here. So this one would be 2 times 500 equal to, I've got 1.2 times t squared. And then we need to divide by 1.2, divide by 1.2. And then this will be given by t squared is equals to that. Now we need to just get to root that. So we would root 2 times 500 divided by 1.2, so that we would actually get to find our time taken. So you will see that the time taken for A, if you use that, so I'm punching my calculator here so that I get to find the time taken for A, that will be equal to, if I punch my calculator, it is giving me the time taken for A is actually equal to 28.8 seconds. And then for B now, we also use the information to choose which equation to use. We can see that for B here, if we use these two, we won't be able to win. We need time, so we can use the third one, because for this one, we are given both of these as well as this one is 0, so this one will be 0. So let's use this one. So we will also get to use that for B to calculate the time taken for B. So the time taken for car B would be simply equal to, I would come and say that change in x is equal to VIT plus half a t squared. So now you would see that our initial velocity is 27.78, and then our acceleration is 0, and then the side I'll be having, so this one is times t. Here I'll be having 500. Now I just get to divide by that, which is 27.878, and then divide by 27.78. So this one will cancel out. So here you'll be left with your time being equal to 500 divided by that. So if we punch in our calculators, the time taken for B was supposed to be equal to, if I say 500 divided by 27.78, I will get a time of 18 seconds. So you would see that the time taken for B would be equal to 18 seconds, whilst the time taken for A is 28.87. So which one between the two actually reached the signboard first? It will be B, because its time taken is less than the one for A. So you will see that time taken for B is less than for time taken for A. So our car B reached there first, reached the signboard first. So our car B reached the signboard first. Now they're saying determine the velocity of car A when it reaches the signboard. Determine the velocity of the car A when it reaches the signboard. Now we now need to determine the velocity of what? Of car A when it reached the signboard. So now what we need to do is, we know the displacement. After knowing the displacement, we know the initial velocity, and then we know the acceleration. We now need to find final velocity. So we are just simply going to use the same equations of motion. So we are going to use the same equations of motion to calculate for car A. So we are now saying that that should be, just pardon me, so that we get to look at which question are we answering. We're answering question number 4.2. So I can actually get to say that 4.2, we need the final velocity of car A, which can be given by initial velocity of that car A plus its acceleration of car A times its time taken to cover that. So you would see that now we calculated time for A. We say that this is equal to what? This was equal to 28.78 seconds. 28 point what? It was 28.87 seconds. 28.87 seconds. And then we are given the acceleration, which is 1.2 meters per square second. And then the initial velocity was 0. So we can calculate our final. So this one will be 0 plus our acceleration 1.2 times 28.787 seconds. So this one was going to give us, if you say 1.2 times 28.7, you were supposed to find a velocity of 34.64 meters per second. So that is how you would have calculated the velocity for car A. Now, let's go to the following section. Just take time to look into that equation. I just want to connect one of my machines. Right. So let's look into that question. So we are saying that the reaction between zinc and phosphoric acid is represented by the balanced equation below. So we are saying that the zinc plus phosphoric acid actually gets to give us zinc sulfate plus hydrogen. So now they are saying that 12.8 grams of zinc reacts completely with the excess phosphoric acid. Now the question is saying, define the term 1 mole of a substance in words. What is 1 mole of a substance in words? So for us to define 1 mole of a substance in words, you would actually get to come and say that a mole is just an SI unit to calculate, or else an SI unit to measure the amount of substance. So we are saying that a mole, represents the amount of substance. So if a mole represents an amount of substance, this becomes the unit of measuring the amount of substance. Now they said 1 mole. Now they said 1 mole. What does 1 mole represent? 1 mole represents 6.022 times 10 to the power 23 entities of that substance. So we are saying that for you to define the term 1 mole, you would have just came and said that 1 mole represents the amount of substance that is equivalent to 6.022 times 10 to the power 23 entities. So you would say that, just allow me to rub here, 1 mole, we are saying that you would say that 1 mole of a substance represents the amount of substance equal to 6.022 times 10 to the power 23 entities of the substance. So we are just measuring the amount of substance that we have. So if we get to say we have got 1 mole, we mean that we have got 6.022 times 10 to the power 23 entities of that substance. So 1 mole can be defined as, or else it represents the amount of substance equal to 6.022 times 10 to the power 23 entities of the substance. Or someone would have said that 1 mole is equivalent to, or else would say 1 mole of a substance is the amount of substance that is equivalent to the same amount of 12 grams of carbon 12. You would also maybe have written this as in this to say that, let me write it here, 1 mole of substance is the total amount of substance equivalent to the amount of 12 grams of carbon 12. So carbon 12 is a carbon isotope which has got 12 grams of what? Of its molar mass. So if you say 12 grams divided its molar mass, which is 12, it will give you 1 mole. So they determined that the amount that was occupied, or else the amount of 1 mole of carbon 12 was equivalent to 6.022 times 10 to the power 23 entities. So they actually used that as being a unity in terms of 1 mole. So you can define that 1 mole in terms of these two. So now let's get to look into the following question. Determine the number of moles of zinc used. Now, how do we determine the number of moles? How do we determine the number of moles? We know that we have got our formulations. We can actually get to use our formulations. Let me show you the formulations that are just in the next page. So these are the equations that we can use when we come to chemistry. So this is for the number of moles, and then this is for concentration, as also as this is for concentration. This is for number of entities or else molecules. And then this one is volume, where this is volume at STP, where volume at STP is equivalent to that. So you can use these equations. So now we are looking for the number of moles. So it will be given by the mass of that substance divided by the molar mass. So we will choose that equation. So we would come and say the number of moles for zinc will be equal to the mass of zinc given over the molar mass of zinc. And then we now need to calculate or else to find the molar mass of zinc. The molar mass of zinc, we can find it from our periodic table. We just have to look for zinc. So our zinc there was here, and then the molar mass would be 65. So we are taking 65 for zinc. So allow me to actually get to move this. So we are doing 5.2. So our 5.2 would be equal to, say, the number of moles. Let me just get to say 5.2. The number of moles of zinc was going to be equal to the mass that is given. They said 12.8 grams divided by the molar mass, which is 65. So the answer there, if I punch in my calculator, this is gram per mole. So that at the end of the day, the answer has to be mole. If I punch in my calculator, I'm actually finding 0.2 moles. So you would find 0.189 or 0.198 something, and then you round off, it will give you 0.2 mole. So that was the answer for 5.2. Now they are saying calculate the number of moles of phosphoric acid that reacts with zinc. Now we need to find the mole ratio of zinc and phosphoric acid. Mole ratio of zinc and phosphoric acid, so that we can determine the number of moles of what? Of phosphoric acid. So you can see that 3 moles of zinc reacts with 2 moles of phosphoric acid. So the molar ratio there is 3:2. When I've got 3 moles of zinc, I will require 2 moles of phosphoric acid. So since I now know the moles of zinc, I will just get to use that molar ratio to actually get to calculate the number of moles of phosphoric acid. So for 5.3 there, I would come and say 5.3 for the zinc and phosphoric acid, the molar ratio there, it is saying 3:2. So now this 3:2, I know the number of moles of zinc, they are equal to 0.2. What about the number of moles of phosphoric acid? That would be x. So for me to find x, I make x the subject. So I will cross multiply here. So this would actually get to lead to x being equal to, I'll bring this up because I brought that side. Bring this up and that one downside. So it will be 2 divided by 3 times 0.2. And then 2/3 of 0.2, that was going to give you 0.13333. But the answer there is just supposed to be 0.13. So you were just going to say 0.13 moles. Those are the number of moles for your what? Phosphoric acid. Those are the number of moles for your phosphoric acid. Now let's go to question number 5.4. Determine the number of hydrogen molecules that form. Now we are looking for the number of hydrogen molecules that form. So the number of hydrogen molecules that form, these are the entities of hydrogen. So also to find that, we need to actually get to determine the molar ratio from this balanced equation. So you would see that the molar ratio of zinc and actually what? Hydrogen would be to say that 3 is to what? 3. So the molar ratio there, it's 3 is to what? Is to 3. So you would require 3 moles of zinc to form 3 moles of hydrogen. So if I divide here, it will be just as 1:1. So the number of moles of zinc that I used are equivalent to the number of moles of hydrogen that I'm going to produce. So I used 0.2 moles of zinc, so I will produce 0.2 moles of hydrogen. So for me to find the number of entities now, I now need to choose a formulation that is in relation to the number of what? Of entities, which is this one. You can see that if I have sorry for that, this one would be to say the number of moles would be to say number of entities over the Avogadro's constant. And this is the Avogadro's constant, which is 6.02 times 10 to the power 23 per mole. So we are just saying that that is the formulation that we use when we are calculating the number of what? Of entities. So let's use that formulation to calculate the number of hydrogen molecules that are formed. So 5.4 was going to say that 5.4 you were going to say are the number of entities of what? Of hydrogen, which comes from the formulation which says number of moles is equal to the number of entities over the Avogadro's constant. So you are looking for the number of entities of hydrogen. So you make this the subject. So your number of entities would be equal to the number of moles times the Avogadro's constant, which is equal to that number of moles for hydrogen molecules. So number of molecules will actually determine that there are 0.2 number of moles, 0.2 moles of hydrogen multiplied by the Avogadro's constant, which is equal to 6.022 times 10 to the power 23. So the number of hydrogen molecules formed were just going to be equal to, if I multiply there, I would get 1. Let's actually get to say it would be 1.204 times 10 to the power 23, or else just 1.20 times 10 to the power 23 entities. So this one would be equal to molecules of what? Of hydrogen. Now that was our question, which is 5.4. So that is what they wanted us to find. They determine the number of hydrogen molecules that are formed for 4 marks. That is how you would have determined. You would have used this formulation to manipulate to find this number of molecules using the Avogadro's constant and the number of moles that you determined from the molar ratio of what? The molar ratio of zinc and of hydrogen formed. So you would see that zinc uses 3 moles to form 3 moles of hydrogen, which is 1s1. And we said we have 0.2 moles of zinc. So there will be also 0.2 moles of hydrogen formed. You use 0.2 times the Avogadro's constant to find the number of molecules. Let's go to the next question. So this is the periodic table that we use. And these are the formulations and the physical constants. Now let's do question number 6. 6.1 is saying a compound is made up of the elements sodium, carbon, and oxygen only. A sample of this compound is found to contain 43.4% sodium, 11.32% carbon by mass. Calculate the percentage of oxygen in the compound. So we are saying that a compound is made up of what? A compound is made up of sodium, and then it is made up of carbon, and then it is made up of what? Of oxygen. And then we have been given the percentage of sodium, which is 43.4%, and we have been given the percentage of carbon, which is 11.32%. So what's missing is the percentage of oxygen, where they total to, if you add them, if you come and then you add there, you are actually going to get a total of what? 100%. So for you to find this percentage of oxygen, you just need to subtract the total of these two from 100. So your percentage of oxygen was just going to be equal to 100 minus the total of these two. So if you add those two, you subtract from 100, you are going to find 45.28% for your oxygen. So for your oxygen, that is what you are going to find there. So that was the what? That was the percent composition for oxygen. Now let's look at empirical formula of this compound. So an empirical formula is something that relates the molar ratio of these three. It's just to see how these three in this compound are actually combined in terms of their molar ratio. So we want to find the molar ratio of sodium and of carbon and of oxygen in this compound. So I would advise us to actually get to use a table for that. Let's use a table for that. So now how are we going to use our table? We are just going to draw a table there where I would actually get to say that I've got columns for what? For elements that are found in that compound. And then I get to say I would calculate what? Because that compound is given as 100%, so I would assume 100 grams of the compound. If I take my basis to be 100 grams of that compound, I would now get to say what is the mass of each compound in that what. So I would actually get to calculate the mass. After calculating the mass of each, I would calculate the number of moles so that I would be able to use this for my what? For my molar ratio. After calculating the number of moles, I will need to find the simplest mole ratio, the simplest mole ratio for each. So the simplest mole ratio, you will find it by dividing by the smallest number of moles that you would have found between those elements. After doing that, you can now actually get to determine your mole ratio for the compound, or else the mole composition. So I've got sodium, and then I would have what? Carbon, I would have oxygen. The mass for sodium in relation to its percentage is 43.4 grams. So if I was to take that compound to be equivalent to 100 grams, the mass of sodium would be 43.4 grams. And then for carbon, it would be 11.32. And then for oxygen, it would be 45.28. And then the number of moles, if I divide this mass by the molar mass of sodium, that would be going to be equal to what? 43.4. I divide by the molar mass of sodium. Molar mass of sodium is 23 from our periodic table. If I divide there, I was going to get what? If I say 43.4 divided by 23, I was going to get 1.89. So you would get 1.886 as you go, but you just get to round off. And then here you say 11.32 divided by the molar mass for carbon. Carbon, its molar mass is 12. So if you divide that, you are going to find something like 0.94. You also divide 45.28 divided by that for oxygen, it's 16. So you would say this one divided by 16, it would actually get to give you something like what? If I say 45.28 divided by 16, it will be 2.83. Now we need to find the smallest number of moles here. It's 0.94. And then we divide throughout by 0.94. So it will be 1.89 divided by 0.94. 1.89 divided by 0.94. This would be approximately 2, because we want the simplest ratio as a whole number. The ratio should be a whole number. So it is 2, and then 0.94 divided by 0.94. You would find 1 there, and then 2.83 divided by 0.94. This one would give you approximately 3. Now the empirical formula, you just need to write these in terms of their simplest ratio. So you would see that here I've got 2, and there I've got 1, there I've got 3. So the empirical formula would just come to say Na2CO3. That was the empirical formula that you were looking for. So that is the empirical formula that we were looking for. So let's go back to our questions. So you would find that the empirical formula of this compound was simply going to come and become what? Na2CO3. So that is sodium carbonate. Now they are saying the molar mass of hydrated zinc sulfate, this hydrated zinc sulfate, is found to be 287 grams per mole. Determine the value of X, the number of moles of water of crystallization. So you can actually get to see that here we are given the molar mass of the what? Zinc sulfate. And then we now need to find the number of moles, which is represented by X of this one. So you would know that the total the total molar mass, which is that 287, is equivalent to the total molar mass of zinc sulfate plus the total molar mass of this water in what? This water of crystallization. So for me to find X, I will need to find this molar mass of zinc sulfate and also the molar mass of water. And then I multiply the molar mass of water by X. And then if I add, they have to total 287 grams per mole. So now I need to find the molar mass for zinc sulfate as well as for water. So let's use the space below here to calculate that. So I'm saying that I need to find, we are saying that the molar mass for hydrated zinc sulfate is given by a total of the molar mass of zinc sulfate on its own plus X times the molar mass of water, so that we can be able to find this X. So now what is the molar mass of zinc sulfate? If you look zinc, we say that zinc has got a molar mass of 65 plus this one for sulfur, it's 32 plus for oxygen, that would be 16 times 4. So I would come here and say 65 plus 32 plus 16 times 4. This added by X times the one for water, that would be 2 times 1 plus 16. And then they are supposed to be equal to 287 grams per mole, the one that I'm given. So I would subtract this from the side and later divide by 18. So this one was going to be equal to 287 minus, if I find the total there, it will be equal to 65 plus 32 plus 96. If you say 16, if you say 16 times 4, we're going to find 64 plus 32 plus 65. That was 161. And then equal to X times 18. And then I will come and divide by 18. And I divide by 18. And then you would actually get to see that that would actually be equal to 287 minus 168 divided by 18. This will cancel out. So this one will be X is equal to, if I say 287 minus 161, I'm going to find 126. And then 126 divided by 18, I was going to find 7 moles. So X is equal to 7 moles. So our X is equal to what? 7 moles. So by doing this that we have done here, we can actually get to agree that this was going to give us X being equal to 7 moles. So the X here that they were looking for, X was equal to 7 moles. We just get to find the molar mass here, which we said it's 161, and then for here, which is 18. So if I subtract 161 from 287 and then divide by 18, it will give me 7 moles. Now let's go to 6.3. A learner needs to prepare 250 cubic centimeters of a solution of sodium sulfate of concentration 1.5 moles per decimeter cubed. Define the term concentration. So you would see that concentration is the amount of solute that you would have dissolved in a solution that is having a volume of 1 decimeter cubed. So to define that, you just get to come, just allow me to rub here. I just want to use this space to define, because we are not going to use this anymore. So to define concentration, you would have just came and said concentration is the amount of solute dissolved in 1 cubic decimeter, in 1 cubic decimeter of solution. That is what we refer to as concentration. So you would see that I'm actually accounting for the amount of what? Of my solute. So it's usually given by that, to say that the number of moles of your solute divided by the volume of that solution, that becomes the amount of solute dissolved in 1 decimeter cubed of solution, because we measure our concentration as mole per decimeter cubed. So that is how you define concentration in words. So now calculate the mass of sodium sulfate required. Now, how do I find the mass being given the volume and the concentration? The best way there is to manipulate this equation to find the number of moles. After finding the number of moles, I later relate it to mass. So you would see that I know that concentration is equals to number of moles over volume. So I can find the number of moles of what? Of sodium sulfate. If I find the number of moles of sodium sulfate there, I can actually get to find the what? The mass of that sodium sulfate from mass over molar mass of sodium sulfate. Because I know that the number of moles is given by mass divided by the what? By the molar mass. So I can calculate the molar mass of sodium sulfate and then use the number of moles that I would have found using the concentration and the volume. So now let's get to see how we would have tackled that. So you would see that here you are given your volume as 250 cubic centimeters. So now we now need to actually get to convert that volume as a decimeter cubed. We need to convert that volume as a decimeter cubed. So you would see that 1 decimeter cubed is equal to 1000 cubic centimeters. And we are given 250 cubic centimeters. So 250 cubic centimeters, you divide by 1000 cubic centimeters, so that you find the number of what? Of decimeter cubed in 250 cubic centimeters. So this one would give you 0.25 decimeter cubed. So your volume that you are given there, it's equal to 0.25 decimeter cubed. And then the concentration that you are given, it's 1.5 moles per decimeter cubed. So for you to find the number of moles, you multiply these two to say concentration times volume. So this was going to give you 0.25 times 1.5. And then if you multiply those two, if you say 0.25 times 1.5, it was going to give you 0.375. So you were just going to get 0.38 moles by rounding off to 2 decimal places. And then after that, you would come and use this same number of moles to calculate the mass of sodium sulfate. You would use it to calculate the mass of sodium sulfate. Now you know that the number of moles of sodium sulfate would be equivalent to the mass that I'm looking for over the molar mass of what? Of sodium sulfate. So all I need is to calculate the molar mass of what? Of sodium sulfate. So the molar mass of sodium sulfate there would be given by 23 times 2 plus 32 and then plus 16 times 4. So we need to find the total of those. So what becomes my total there? Let me just get to use my calculator. So if I use my calculator to find the molar mass of sodium sulfate there, I would find a total of what here? So my total there would simply be equal to what? It will simply be equal to 98. So here I would find 98 because if I say 23 times 2 plus 32 plus 16, sodium sulfate. I'm looking for the one for what? For sodium sulfate. That one is not equal to 98. I think this value is wrong. So we are supposed to actually get to calculate there so that we find the one for what? For sodium sulfate. So the one for sodium sulfate, if I actually get to multiply by that, is it sodium sulfate or else it's sodium what? Because I can see that the values that I have here, they are not tallying. So let's look at our question. Just so we are saying sodium sulfate. So if it's sodium sulfate, now if I punch in my calculator, why is it that I'm finding the different values? So I would say that 23 times 2, that will give me 46 plus the 1 for sulfur 32 and then plus the 1 for oxygen that is going to be 64 and then I would get 142 here. So after finding 142 I would actually get to use that 142 here and then I've got to 0.3 and then when I find my mass it will be 0.3 times 142 and this one was going to give me 0.3 times 142. It was going to give me a mass of 97.2 grams. So we are looking for the mass of sodium sulfate. So the mass for sodium sulfate there, it was just going to be equal to what? 97.2 grams. So that was the mass for sodium sulfate. So just make sure that you are calculating the mass of the what? Of the given compound. So the mass for sodium sulfate was supposed to be equal to 97.2. Now let's go to the next question. Now I have got question number 7. Question number 7 is saying a sample of sodium carbonate of mass 20 grams reacts completely with excess nitric acid of concentration 1.5 moles per decimeter cubed. The reaction is represented by the following balanced equation. 7.1 is saying calculate the number of moles of sodium carbonate that reacted and also calculate the volume of nitric acid in decimeter cubed required to completely react with the 20 grams of sodium carbonate. And then now we are saying that a sample of sodium carbonate of mass 20 grams. So you are given your mass for the sodium carbonate and then it reacts with the nitric acid with that concentration. So if you are given that and they want you to find the number of moles of sodium carbonate that reacted, the number of moles of sodium carbonate, we will find it from our formulation which says mass over molar mass. because we are given the mass of what? Sodium carbonate. So we need to find the molar mass of this. So we would actually come and say that, let me just get to wrap this and write it neatly in a way to say the number of moles for sodium carbonate will be equal to the mass that you are given for sodium carbonate over the molar mass for sodium carbonate. So you would see that the mass that was given as 20 grams divided by the molar mass, that would be to say 23 times 2 plus 12 and then 16 plus 16 times 3. So I would come here and then I'll say 23 times 2 plus 12 plus 16 times 3. And then this was actually going to give me, a value of what? If I say 20, divided by 23 times 2 plus 12 plus 16 times 3, I was going to get the number of moles to be equal to 0.19 moles. So the number of moles there were 0.19 moles. So that was for the number of moles for sodium carbonate. These are equal to 0.19 moles. Just punch in your calculators to confirm and cross-check these values. But what's most important is how we get to find those values. You need the mass that you are given, which is 20 grams, and then the molar mass for this compound. And how do we find the molar mass of this compound? We actually sum up the mass of each atom that we have here. So we have got 2 atoms of sodium and then 1 atom of carbon and 3 atoms of oxygen. So you need to go to your periodic table, look them up, what is their atomic mass, and then you sum those. You find your molar mass. And then you divide. After dividing, you are supposed to find 0.19 moles. And then we get to say that, let's look at the following question. The following question is now saying that the volume of nitric acid in decimeter cubed. So we need to find the volume of nitric acid in decimeter cubed. So to find the volume in decimeter cubed, we need to look at the mole ratio of what? Of sodium carbonate and nitric acid, because we know the number of moles of sodium carbonate that reacted. So we now need to know the number of moles of nitric acid that also reacted, so that we can convert those number of moles into volume. So the mole ratio there is 1:2. So if I have got 0.19 moles of what? Of sodium carbonate, then I would have 2 times 0.19 moles, the number of moles of nitric acid. So the number of moles of nitric acid there that reacted would be equal to 2 times the number of moles that we have calculated for sodium carbonate. And if I multiply 2 and 0.19, I should actually get 0.38 moles. That should give me 0.38 moles. 0.38, because I'm saying 0.19 times 2. That is 0.38 moles. And then now I have got the number of moles for sodium carbonate. Since I now have got the number of moles, for nitric acid, I will just need to calculate the volume for that nitric acid. And how can I calculate the volume in decimeter cubed of nitric acid, knowing the number of moles as well as the what? As the concentration. Because I was given, mind you, I was given the concentration for nitric acid here. They say that the nitric acid's concentration was 1.5 moles per decimeter cubed. So with the number of moles, I can use my concentration and the number of moles to manipulate those. So I know that concentration can be calculated by number of moles divided by the volume. So if I want to find volume, I'll make volume the subject formula. So it will be volume is equal to number of moles divided by the concentration. My number of moles, it's 0.38 divided by 1.5. So this is 0.38 moles. This is moles per decimeter cubed. So the value that I'm going to find, it has to be in decimeter cubed. So if I divide that by 1.5, I should find 0.25 decimeter cubed. So my volume there would be 0.25 decimeter cubed of what? Of nitric acid. So I just used this formulation of concentration to say concentration can be found by saying number of moles of solute divided by the volume. So we know the number of moles and we know the concentration, so we can certainly find the volume. Now let's go to the last question. The percentage yield of carbon dioxide in the reaction is 85%. Calculate the actual volume in decimeter cubed of carbon dioxide that was formed. So we are told that whatsoever is formed here, the actual volume that you are going to get, it's 85%. So according to this reaction, what we are going to actually get to find, the actual volume that was yielded there, it's 85% of it. So we need to find the mole ratio of our sodium carbonate as well as the carbon dioxide that was produced. So you would require 1 mole of sodium carbonate to produce 1 mole of carbon dioxide. So their mole ratio is 1:1. So if I know the number of moles of sodium carbonate, I also know the number of moles of what? Of carbon dioxide. So if that is the case now, let's actually get to look at how we would have used that information to find the actual volume that was yielded in this reaction. So you would see that due to that mole ratio, the number of moles of carbon dioxide that was produced according to the ratio. So if it's according to the ratio, we call this theoretical. So these are theoretical values because we are using what? We are using that reaction. So these were supposed to be equal to 0.38 mole. Sorry, this one is for nitric acid. So for the sodium carbonate, we found 0.19 moles. So that 0.19 is equivalent to the number of moles of carbon dioxide. Now, to find the volume, we would simply get to say we don't have the concentration for carbon dioxide. So we cannot use this manipulation that we have used. But however, what can we get, or else what information can we find readily for carbon dioxide? We can find its molar mass. So by finding the molar mass of carbon dioxide, what is it that we can actually get to use to find the volume? We know that the number of moles can actually be given by what? Can actually be given by mass over the molar mass. But however, this does not give us volume. Then we need to actually get to find something else. We also know that the number of moles is given by the volume of that substance divided by the volume at STP, where we know that the volume as STP is given by 22.4 decimeter cubed. What are we saying? We know that 1 mole of gas occupies 22.4 decimeter cubed. So if I have got 0.19 mole of that gas, how much volume will it occupy? That is what I'm now looking for. So let's just get to erase things to do with the molar mass. So for me to find the volume, of carbon dioxide, I would have to come and say the number of moles. I would have to just come and say the number of moles times the volume at STP. So you would actually get to see that if you do that, you would end up having a volume that is equivalent to 0.19 times 22.4 decimeter cubed. And this is going to give you a volume of what? Let's multiply 0.19 times 22.25, 22.4, and that is going to give you a volume of 4.256. We round off, this is going to be 4.26 decimeter cubed. But however, we have been told that this is a theoretical value. So this one is what we refer to as what? A theoretical value. Why? Because this is coming from our what? Our reaction equation. But in actual essence, they told us that the percentage yield of carbon dioxide, when that reaction actually occurs, it gives 85%. So the actual volume is 85% of this. So for us to find the actual, you would actually get to come and say 85% of that theoretical volume, and then you just get to find your what? Your total volume there. And then that would be equal to, if I multiply by 85%, that will give me 3.62 decimeter cubed. So that is what you were supposed to calculate there. So this marks the end of our question paper. Thank you so much for being together. This was a long question paper, but however, I'm sure you managed to grasp one or two important things out of this revision. So let's try to use that information to actually get to prepare for our upcoming exams. Thank you so much for being together. Let's meet again in our next videos to come.